All right, so we are going to finish the year solving logarithmic equations, and that just means there's a logarithm somewhere in the equation. And half of the battle with solving log equations is recognizing the difference between types of equations with logarithms. For example, this just has a single logarithm in it, but this one has a log on both sides. This one has two logs, but they're on the same side. So the technique for these three different situations is different. So you really have to look at your expression first. If you only have a single log in your equation, that's why this says log on one side of the equation. You want to get that logarithm by itself. So I would subtract this 7 first, get that 7 moved away, and then I'd have log of 3x plus 1 equals 2. And then you do the exact opposite of what you did when you had the exponential. Is you wrote it as a log. Now to solve the log, I write it as an exponent. And the base of this log is 10, so rewriting a log as an exponent would be putting the base, which is 10, to the second power. This is what we did a few classes ago, and that equals the input here of 3x plus 1. And then you're really set to go like a regular algebra problem. And I am writing larger than maybe you did if you were able to print this off, but 10 squared is 100. So I'm just going to continue this over here. I'd have 100. That would equal 3x plus 1. And then if I subtract 1 from both sides, I would have 99 equals 3x, and divide by 3, and I would have 33 as my answer. So I didn't really show you the last couple steps for each of those, but that's how you would do it. So if there's a single log, you get the logarithm by itself. So I still have to move that 7 just like we normally would if this were my variable. And then when I have that single log, I rewrite it as an exponential. The base of the log, exponents on the other side, that's your answer. Now this is my favorite kind. I have a log on both sides. This is the natural log, so these are both those base e. But if you have a single log on the left and a single logarithm on the right, what that means is these two inputs have to be equal. This is just like the exponential ones that had the same base, and you set the exponents equal. Well, I have two logs of the same base. They're equal to each other. That means 2x minus 3 has to equal 11. And again, now it's just a regular algebra. I'm going to add 3 to both sides, and I'll get 2x equals 14. And then I divide by 2, and I get x equals 7. And again, the only reason I'm not showing you those steps is I sort of don't have enough room to do it because of how large I'm writing. All right, now we're going to move into the whole point of us having those properties or practicing those properties for a day is it allows us to solve these equations a little bit nicer. So on this one, I've got two logs, but they're on the same side of the equation. Up here, the logs are on different sides. That was great. Here, they're on the same side, and this isn't a log. So the first thing I'm going to do is condense these two logs into one log using my properties that we practiced. And I'm adding the two logs so I can rewrite this as a single log, log base 9, and I can multiply these two things together. So I'm going to be able to multiply 5 and x minus 8. And I'm going to do that in a minute. That's going to end up being a little distributive property. And I'm going to do two steps in one. First off, I now am down to a single log, just like I was up here right above it. I have a single log and a number on the other side, so I can rewrite this as an exponent. The base is 9. I come over here, this becomes my exponent, and it equals what's inside the log. Now inside the log I have 5 times x minus 8. I'm going to distribute and get 5x minus 40. And now I have a regular algebra problem. I'm going to switch colors. I'm going to add 40 to both sides. So I'm going to have 5x equals, this is 81. 9 squared is 81. So when I add 40 to that, I get 121. And my last step is to divide that 5 away. And if I divide 5 from 121, I do not get, and it doesn't go in there evenly. So I'll either have a decimal or I'm happy to leave it like this. And that would be your answer. So this is very similar. Two logs on the same side of the equation, and this is just a regular number. So again, you want to identify your situation before you attempt to solve it, because there's different strategies. Here, they're on the same side. I'm going to condense them using our properties of logs from the other day. So log base 3, and subtraction means I can take these two things and I can put them in here as division. So 2x divided by x minus 3. So that was the whole point of practicing those properties. So you kind of knew what to do with that side of the equation. And now we can go back to solving just using a regular idea from up here that keeps ending up being a final step. I'm going to I have a single log, a number on the other side. And so I rewrite this as an exponential function. This is the base, 3 to the first, because this is my exponent. Remember, that's all a log is it gives you an exponent. And this is my input. I can't really do anything with that right now, so I'm just going to write it as 2x over x minus 3. Now, 3 to the first is just 3, right? So I don't need that 1 there anymore. And I am going to write, because I have a ratio over here, I'm going to write this as a ratio. And the only reason I'm doing that is it allows me now to cross multiply, which is an excellent solving technique when you have a ratio. So it'd be 3 times x minus 3 equals 2x times 1. I know you guys have seen that before. I've got to pop that 3 inside of there. So I distribute again. 3x minus 9 equals 2x. And again, my solving box isn't big enough to finish this. So I'm going to write it down here and then I'm going to erase it. But I would add 9 to both sides. So if I plus 9 here and I add 9 here, then these guys are gone. And I would take 2x away. And if I come over here and take 2x away, then 3x minus 2x would leave me an answer of x equals 9. And that would be my answer. All right, we're almost done. We're really close to being done, which is pretty exciting, I'm sure. Let me check and make sure these answers are all acceptable, and they do seem to make sense. And I will tell you why in a minute, because I think I end up with one that maybe doesn't work. And then I'll explain what I'm talking about. I was just double checking. All right, so here we are. This is a whole new situation. This is just full of logarithms. Log, log, log. So logs everywhere. Everything has a log. So this is going to require me to do this idea of these logs on this side. I'm going to be able to put together into a single log. That's why we practice all those properties. And then I'm going to have a situation like this where I'll have a single log on each side of the equation, and my life's actually not too bad because I can then just solve what's inside. So this, I've got to apply the properties that we've been practicing. This 2 out in front comes up here as an exponent. Remember that number in the front pops up as an exponent. I'm adding, so I can write this as log base 3 of 3 times x squared. So I write it 3x squared equals log base 3 of 48. So again, I just apply two properties. The multiplier in front can become an exponent inside that one log. I'm adding two logs of the same base, so I can write them as a single log, and I can use the multiplication property. And now I have log base 3 and log base 3, the same exact log on both sides, which means that 3x squared has to equal 48. Divide both sides by 3. I get 16. Take a square root. And we have to be careful because that could be 4 or negative 4. And this is what I wanted to be careful of and talk to you guys about. You are going to encounter quadratics every once in a while when you're solving logs, and we have a lot of techniques for solving quadratics. This is one that was really nice because I just took a square root. That was one way to solve a quadratic. You might have to factor to solve a quadratic or quadratic formula. Anyway, a lot of times you get two answers with a quadratic. What we didn't get to this year because we ran out of time is graphing logs. And when we graph logs, we would have seen that you can't have a negative input in a log. The log graph, if you remember that very first day, comes up like this. And you'll notice that it doesn't cross this y-axis, which means there are no negative inputs. Negative numbers are not in the domain of the log graph. It's specifically and exclusively living on the right side over here, which means this answer, if I were to plug it back in here, would not work. It wouldn't give me, it just simply doesn't exist. So this is a false answer. So what I was doing a minute ago is I was looking at all my answers and making sure when I plugged them back in, it didn't equal 0 or a negative number inside the logarithm, because that's not allowed. So sometimes you end up with a false solution, and that was the case here. So my only answer is actually x equals 4. It doesn't happen very often, but something to watch out for. And now the last way, again, notice we're down to a single log, which is not, well, actually, it is just like this one right here, what we started with, after we did some steps. But there are no algebraic steps to isolate this log by itself. There's nothing on the being added over here or subtracted, so it's already ready to go. It's just a natural log, but I still going to do the inverse. I'm going to rewrite this as an exponential. So that means I'm going to write it as the base, which is e, to the 7.25 power, and that equals x. And that is my answer. And if I wanted to, I could use my calculator to get an approximation for this, which I would come down here and I'd be e to the 7.25. Now remember, e is right here on my calculator. You should have an e to the x button. So I hit second e to the x. It's the inverse of natural log. That's why it's in there. And I'm putting that to the 7.25. And I hit enter. And I get a very large number, 1408.1. And so I can write 1408. And I'm approximating. So sometimes if you ended up with a log as part of your numeric answer, or an exponent as part of your numeric answer, you use your calculator, you're going to get an approximation. All right, so that's it for solving. It's a lot. There are some consistent things that happen, but there's twists and turns that are different. So you've got to really look at the problem first and decide which of the scenarios you have. Use this as a guide to see what the problems look like, to give you a helpful hint as to which approach to start with. But often when you get to a certain point, there's only two approaches. One is to rewrite your log as an exponent, and the other one is, if it's logs on both sides, you just solve what's on the inside of the logs. But you've got multiple steps to get there depending on the start. So there you go. That's your video lesson, probably the last lesson of the school year. I know, probably pretty sad about that. But there you go. Enjoy and have a fantastic day.